Okay, so what's going to be on your unit exam on Wednesday? All right, we'll start right at the beginning of the unit. Okay, and the first thing we talked about were forms of energy. Okay, so we talked about chemical energy, nuclear energy, electrical energy, magnetism, all of that kind of stuff. Okay, and certainly there could be some multiple choice questions where we talk about that. Okay, so I'd give you a situation involving some form of energy, and you would have to identify what type of energy was being used. I don't care what form of energy was being used. You would definitely need to know the systems as well. Okay, so systems here. Okay, open, closed, and isolated. Again, that's going to be multiple choice type material. So those are going to be pretty straightforward recall type questions. Okay, need to know about thermodynamics, heat engines, and heat pumps. Okay, and a little bit about maybe why perpetual motion machines can't exist in terms of the laws of thermodynamics. Okay. And it is possible that there could be a question where you would actually have to write out an explanation answer for that. Okay, I mean, there's certainly going to be some multiple choice about that, but there could also be a written response question where you're asked to explain, okay, maybe why a perpetual motion machine can exist, or how a heat pump would work, or something like that, based on the laws of thermodynamics. So, does that mean you need to review the laws of thermodynamics? Yes, it does. Okay, so make sure you go over that thing that's basically right at the start of this unit, okay, where we talked about those, the first law of thermodynamics being the law of conservation of energy. Second law of thermodynamics talks about heat moving from hot to cold, okay, that kind of stuff. Okay, then we moved on to scalar and vector quantities. Okay, and it's not so much that you need to memorize these because I'm going to go, which of the following is a scalar quantity? Although I mean, I could do that in the multiple choice. But more importantly, you need to know that so that in the problem solving, if I ask you to calculate the velocity of an object, you calculate it the right way. Okay, because if you go and you go distance over time, and I've asked you to calculate velocity, you're probably not going to get the right answer, and you're certainly going to forget to put a vector on it. Okay, so we definitely need to know which things are scalar and which things are vector for the problem solving part. Okay, so our vector quantities are velocity, displacement, acceleration, and force. Okay, our scalar quantities are speed, distance, time, energy, and work. Okay, work is also scalar. Suppose I'm going to ask you to do some V equals D over T problems. Okay. If I do, it will most certainly be a question where it's a couple of parts. Okay, like a bus makes a trip made of two sections. First they go north, in this amount of time, and then they go south at this velocity for this long, and calculate the average velocity over the whole trip or something like that. Okay, a lot like the ones we did in class on our worksheets. So if you've forgotten how those work, might not be a bad idea to look over the podcasts of some of those early quizzes, okay, and worksheets and things like that, okay, so that you know what we're doing. Okay, so remember, guys, that speed, that's this v here, okay, is distance over time, and velocity is displacement over time. Okay, keeping in mind which one's which. Okay, graphing. Holy smokes, do you need to know your graphing? Okay, there is a ton of graphing on this test. Some in the multiple choice, some in the written response. Okay, you are not going to be asked to construct a graph. Okay, I won't ask you to do that, but I may have a graph constructed that is missing parts that you will have to identify and fill in. And there are several questions that are strictly, here's a complete graph, I want you to calculate something from it, or several somethings from it. Okay, so here's a velocity versus time graph, calculate the displacement of the object, or calculate the acceleration of the object between 5 and 10 seconds, or something along those lines. So we definitely need to know what we can get from each kind of graph and how we get it. Okay, super important there. There's a ton of marks available on this exam to do with graphing. Right? None of those calculations are difficult, okay, but you have to remember how to do them. Okay, so little things, okay, that we want to remember in using graphing. Okay, this formula here, and you don't have to memorize your formulas. Okay, you're going to get the formulas all on the front page of the test. Okay, you don't get to use your formula sheet because I don't know how much you've written on it. Okay, displacement is final position minus initial position. So if I'm dealing with a position versus time graph, okay, like I am right here, okay, if this is my final position and this is my initial position, I just subtract the two and I've got the displacement. Right? If I want to find the average velocity, okay, then I can go v equals d over t, or I can find the slope of the line. Okay? Make sure you read the question carefully in case it specifies exactly how it wants you to find something. If the question says, using your line, do the following things, make sure you're doing that. If you're using points that aren't on the line, are you using your line? No. And I'm pretty sure that if I did that, and I did, pretty sure I bold-faced, italicized, underlined, using your line. Okay, just to make it stand out so you would notice it. All right, so that's a big deal on that one. Okay, yes, y equals mx plus b. Yeah, you can use that on the test. I mean, if you don't like using y equals mx plus b, you can probably get by with rise over run. Okay, but being able to use y equals mx plus b is going to be useful. Right? If I'm dealing with a velocity versus time graph and I want to find the displacement, how do I get it off of this graph? Anybody remember? Ooh, guess we better review that. Might want to look that over tonight. Okay. Yes, that's exactly what you do. Calculate the area underneath the line. Okay, I'm going to take the area of this triangle, that's the base, times the height over 2, and remember that that means I'm using the average speed multiplied by the time, all right, which is exactly this formula right here. Okay, average speed is distance over time, so if I multiply the average speed times time, I'm getting the displacement. Okay, that's where that formula comes from. All right, if I want to find the acceleration on that graph, then I can use 2 points on the line and calculate the line's slope, right? Because the units for acceleration are meters per second squared. If I find the slope, I'm dividing meters per second by seconds, and that's meters per second, meters per second squared. Okay, little things like that are going to be important for you to review. All right, so yeah, definitely know your graphing. Okay, then acceleration. There's going to be some problem solving to do with that. I think I have one really easy one in the multiple choice, but then I have one that's a little bit more complex in the written response. Be mindful of ways that I can make a question seem like it doesn't give you enough information, but actually does. It is possible for me to ask you a acceleration question and only give you one actual number in the question, and then use words and the situation to make you figure out the rest of it. For example, if I was to drop something from a building and ask you what speed it would be going when it hit the bottom, okay, if it fell for 7.5 seconds. Okay, I gave you one number, 7.5 seconds. What else did the question imply? Nope, it's an acceleration question. Okay, that it hit the ground. Yes, but I'm talking about the speed the instant it hits the ground, not after. But yeah, I see where you're going there. Okay, I dropped it. What did I give you? Okay, gravity's involved. I don't have to give you that number. You know it's falling. Okay, and that number's on the formula sheet and on your test. What else did I give you if I dropped it? Okay, still not to do with potential energy, but no initial. What's VI if I drop it? 0. Okay, it's an acceleration question. Now, there's the trick. Okay, I talk about something falling, and immediately we're thinking about energy. But if it's asking about speed and time, and it's giving you time, did we ever use time in an energy question? Okay, no we didn't. So that's another thing to look at. What did this question give me? Write down your givens. If you see something that you haven't had to do an energy calculation, it's probably not an energy calculation, right? Match that stuff up with your formulas. In the question like that, I gave you VI, I asked for VF, and I told you A was 9.81, and I told you the time was 7.5 seconds. Okay, I'm looking at that and thinking that's not what I would get in an energy kind of question. Agreed? All right, so it's really important to write those givens down. So yes, there's going to be some acceleration problem solving on that test for sure. Work energy theorem. Huge. Okay, there's no other way to say it. It's huge. Okay, there's going to be a ton of marks. More marks about work energy theorem on this test than anything else. Graphing is second. Okay, work energy theorem is first. There are several large mark problems and lots of multiple choice about work energy theorem. Do you have lots of examples? Yes. Okay. I mean, I went over about a half a dozen examples a day for a week. Okay. Not to mention all the ones that we did off the worksheets. Okay, and your quizzes and all that kind of stuff. So make sure that you go over those things, okay, in the podcast or in your notes or whatever, so that you know how to solve those kind of problems. Okay, conservation of energy. EI equals EF. Okay, roller coaster, sledding down a hill, going down a slide. Okay, you know, any number of situations where essentially gravity is the only thing involved. I think that's a 8-mark question on the test. Okay, 8-mark problem, and then there's some stuff in the multiple choice, you know, kind of knowledge-based stuff about law of conservation of energy as well. Okay, so remember, EI equals EF, okay, looking for the mechanical energy here. The mechanical energy initial equals the mechanical energy final. Calculate what you need. And then what we went over today, last thing, okay, efficiency. Okay, so efficiency is work out over work in. So it doesn't seem like there's like all that much. But obviously there could be a variety of kinds of problems, okay, to do with each one of those things. How many of you did the review package over the weekend, or at least started it? Okay, good. Most of those questions I took off of tests I don't use anymore. Okay? So it would be advisable, if you have not already done those, to do them. Okay, especially tonight, because you have chance tomorrow to ask questions. Okay, so make sure you do that, guys, and take advantage of that. Please don't leave all of your studying until tomorrow night, because you will find yourself short of time almost certainly. Okay, any questions on that stuff there? Okay, well, I hope you have lots tomorrow. Okay, there will be a quiz tomorrow at the start of class. Okay, conservation of energy, I'll post it later on today. Okay, don't pack up. Take out your review package, because there's still about 5 or 6 minutes left in class, and that's what you can be working on. Okay, and then tomorrow we'll go through any questions that you have in regards to that.